Hi everyone. I wanted to take a few moments today and show you one of the most used strategies in 4th grade math, and that's a strategy that we call the area model. So we use the area model for 2-digit times 2-digit multiplication. So this type of multiplication takes students' skill of multiplying up to a 4th grade level because both numbers have a digit in the tens place, and this can really call for a lot of place value errors. However, using something like the area model has proven year after year to be a really helpful strategy that helps all of my students multiply 2-digit numbers by 2-digit numbers. So what it is a square or rectangle, some kind of box of sorts that we sort of partition off into these 4 sections. So let me explain what each section is for. Let's say we were going to multiply something like 42 times 56. What we would do with these two numbers is we're going to take the value of each digit and pull it apart into expanded form. So 42 becomes 40 and 2. 56 becomes 50 and 6. Now, using area or length times width, we find the area of each of these boxes. However, students aren't familiar with things like 50 times 40, but they are very familiar with 5 times 4. That's going to equal 20. But because this is actually 50 and this is actually 40, they also know that that power of 10 is going to bump this number up 2 more place values, and 50 times 40 should be 2,000. Now, the answer to a multiplication problem is called a product. However, since these are just part of the answer, these are going to be called partial products. And when you are multiplying a 2-digit number by a 2-digit number, you should have 4 of those. So let's continue to find the other ones. This next one over here, if this is 50, this is 50. I'm going to take that 50 that I multiplied by the 40 and do 50 times 2. I know that 5 times 2 is 10, and I can just bump that up because it's actually 50 times 2. That gives me 100. Now, this length here was that 40, so this is 40. And now we have that 6 times 40. I know that 6 times 4 is 24, and I just add my 0. And then my last one is going to be that 6 times 2, and that should be a math fact. This bottom right corner should always be a math fact. Now, I'm going to take my 4 partial products, and I'm going to add them together, and that's going to give me my total answer. Now, something that's crucial is I've done all this huge multiplication. I don't want to mess up on something like my addition, so I want to make sure I line up all my digits by their place value and take my time adding these all together. And then I can see that my answer is 2,352. So that is the area model. I'm going to do one more question just to show that all again, and maybe show you another way it might look on your students' work. This strategy is something that a lot of people in general are kind of shocked by and a little like, wow, that's how y'all do multiplication now? But it really just ensures that the value of each digit isn't lost, like it might be doing something like standard algorithm. Let's see, let's do 76 times, why can't I make up numbers right now? 53. So I'm going to start by pulling those numbers apart. I've got 70 and 6, got 50 and 3. Starting with this 50 times 70, I know 5 times 7, that's going to be a math fact of 35, but I have these 2 place values I need to bump up. I'll sing a little song to the students. I'll say, bump, bump, bump it up, bump, bump, bump it up, times 10, because this is not just 5, it's 50. This is not just 7, it's 70. So they need to bump it up twice. So just letting you know where that song came from. Don't let your students take credit for that one. That was me, Miss Melton. 5 times 6 is going to be 30, and then I bump it up. Get my 300. Moving down here, I have 3 times 70. Boom. And then I have that 3 times 6, which is going to be 18. Another thing I want to point out is that I've used each of my factors twice. I have 50 and 50, 70 and 70, 3 and 3, 6 and 6. That's why this area model is so crucial, because when a student is doing traditional standard algorithm multiplication, they usually start with something like this, that 3 times 6, 18, and then they carry that 10. Then they're going to do 3 times 7, which would be 21, but they add 1, and then this is where it starts to get crazy. I learned that you X's and O's. At the time, I had no idea why I was doing that. We cross out that digit in the ones place because we are done with the ones. I'm now multiplying by this 5 that is in the tens place. Nothing times 50 is going to equal something in the ones place, which is why we put that X and drop our O. This, however, is all kind of quick and complex, as opposed to something like this that's more concrete and representative of where the value of these digits come from. So I'm going to discontinue this. However, I do want to say that standard algorithm is not bad. I don't want you to absolutely just move away from it. And I will even have some students move to standard algorithm during this school year. However, I've noticed in the past that area model is almost a flawless strategy. And if I can get a group of 4th graders to multiply perfectly every time, even if it is something like this, I'm going to do this. All right, going back to my strategy, I'm taking my 4 partial products and I'm adding those together. And I have my answer, 4,028. So again, this is your area model strategy. This is our 2-digit by 2-digit multiplication strategy. This is what we want our students to use, and I hope this helps you practice with them at home. Feel free to help them with their homework, or even take time to just generate random numbers and have them practice. I know that after this week, most students should be super comfortable with this strategy, and this should be something that they do with great success. Thank you so much for watching. Have a great rest of your day. Thank you.